On June 30 in the 1908, in the deep forests near the Podkamenaya Tunguska River, life was slow and ordinary. Most folks lived far from one another. They hunted, they herded animals, and they followed the quiet rhythm of the land. But before the sun rose high, a bright light moved across the sky. People who happened to be awake saw something glowing and fast, almost like a burning ball far above. A moment later, there was a flash, and then a heavy sound that rolled through the ground. Trees shook and fell. Some people said it felt like the sky itself had cracked open. Years later, the explorer Leonid Kulik came to the area to look for answers. He walked through miles of fallen trees, all pointing away from one place. Yet he found no deep hole in the earth. It seemed whatever had come from the sky had burst high above, leaving only the great ring of broken forest behind. If you enjoy peaceful history stories, consider subscribing. Anyways, let's dive into today's tale. The days that followed the strange flash in the Tunguska forest were confusing for the people who lived in that quiet land. Life there was already hard. The summers were short, the winters were long, and the forests felt endless. Most people did not have much contact with the outside world. News moved slowly. So when something unusual happened, it took time for stories to spread and longer still for anyone to understand what those stories meant. Some of the first people to describe the event were Evenki herders. They were used to watching the sky, the weather, and the land around them. They could often tell when a storm was coming. They could tell where an animal had walked just by looking at the ground. But what they saw on that morning in 1908 was not something they had words for. Some said it looked like the bright tail of a falling star. Others said the sky seemed to open for a moment. A few said the air felt hot, even though it was still early. Many of them described a long trail of light moving across the sky. It was bright enough that people noticed it even through thin clouds. Then came the flash, which was stronger than anything they had seen before. It was not like lightning. It did not flicker. It just came once in a sharp, sudden way. The air after the flash felt heavy, as if the land was holding its breath. A short time later, a deep sound rolled across the forest. Some people heard it as a single boom. Others said they heard several bangs, one after another, like distant gunfire that echoed. The sound carried far across the trees and over the rivers. It reached places where people had not seen the flash at all. Some people even fell to the ground because the shake was so strong. They did not know what had caused it. They only knew the earth had moved. In the days that followed, stories spread from one camp to another. Some people packed their things and moved away, not wanting to stay near a place that felt touched by something strange. Others stayed, but they walked with more care. Hunters noticed that large areas of the forest were now silent. Trees that had stood for years were lying flat, all pointing away from a center they could not see. Animals had run from the area. Birds were gone. Footpaths were blocked by fallen trunks that stretched as far as the eye could reach. For a long time, no one from the outside world came to look. Russia at that time had many other worries, and the Tunguska region was very far from big towns. Only years later did scientists begin to hear the stories. At first, people who worked in cities found it hard to believe. How could such a huge event happen in the open and not leave a clear hole in the ground? Many people thought the story must be mixed up or made larger than it was. Some said it could have been a volcano, though there were no volcanoes in that part of Siberia. Some said it could have been a rare kind of storm. Others quietly wondered if something from space had fallen toward the Earth and broken apart. As the years passed, more small reports came in. A few travelers who passed near the area wrote down what they saw. They spoke of hundreds of square miles of forest laid flat. They described trees with branches burned off. They said the land felt strange and empty, as though a strong hand had swept across it. These notes reached the ears of scientists in the early 1920s, and that is how Leonid Kulik became interested in the story. Kulik was a man who cared deeply about studying meteors and other objects from space. He believed that the Earth had been hit many times by things that fell from above, and he hoped to learn what they were made of. When he heard the Tunguska reports, he felt sure that this must have been one of the largest such events in human memory, so he planned a trip, even though he knew it would be hard. Traveling to the Tunguska region at that time was no simple matter. Trains could only take him part of the way. After that came long rides on horseback, and then days of walking through forest and swamp. Kulik and the small group with him had to carry their food, tools, maps, and notes. They often had to rely on local guides, who knew the paths better than anyone else. Even with guides, the land was rough. Streams were cold and deep. The ground could be soft and wet. Mosquitoes were thick in the summer. But Kulik kept going. He believed he would find something worthwhile at the end of his journey. When he finally reached the area where the flash had been seen, he was surprised by how wide the damage was. He wrote that the trees were all lying in the same direction, pointing away from a center point like spokes on a wheel. In the middle of this great circle, some trees were standing but stripped of their branches, burned and bare. He had expected to find a crater, a large hole in the ground where a meteorite had struck. But there was no hole. The land in the center looked broken and burned, but not deeply dug. This puzzled Kulik. If something had fallen from space and hit the ground, it should have left a mark. The heat from the blast should have burned more of the land. But instead, it looked as if the force had come from above, not from the ground. Kulik began to think that the object must have burst in the air, several miles up, and the shock wave from that burst had knocked down the forest. The more he looked, the more this idea made sense. The people who lived near the Tunguska region had their own thoughts. Some believed it was a sign from the sky. Others believed it was a natural event but still feared it. They pointed to the warm wind that blew after the flash and the strange red sky that some said they saw that night. Some travelers in faraway countries even wrote reports of bright skies at night in the days after the event, though it is still unclear how far the glow really reached. But the idea of the sky turning red or bright made the Tunguska story feel larger than just one place. It felt like something the whole world might have noticed, even if only for a short time. Over time, many scientists thought about what could have caused such a blast. The most common idea was that a large rock or piece of ice from space, something like a small comet or an asteroid, had come into the Earth's atmosphere. As it fell, the air around it would have become extremely hot, causing the object to break apart before it reached the ground. The burst would have sent a shock wave down toward the trees, pushing them over and burning some of them. This idea fit many of the marks that Kulik had seen, though he still wished he could find some pieces of the object itself. Kulik kept returning to the Tunguska region in later years, hoping to find fragments buried under the soil or hidden in the swampy ground. The work was slow and difficult. He faced cold weather, sickness, and shortages of supplies. Still, he believed that the mystery was worth studying, even if he did not find clear pieces of the object. He thought that understanding the pattern of fallen trees and the burned land would help people learn about dangers from space. He wanted to understand how often such events might happen and how strong they could be. As the years turned into decades, scientists used better tools to study the event. People made maps of the fallen trees. They used old notes, new reports, and new methods to estimate the force of the blast. Many came to believe that the explosion may have been as strong as a large nuclear explosion, though it happened many years before such weapons were made. But the key difference was that the Tunguska blast came from nature, from an object falling into the atmosphere from far away. Even now, the Tunguska event is still studied. People try to understand exactly what kind of object caused it. Some think it was a stony asteroid. Others think it was a fragment of a comet made of ice and dust. A few even look for very small pieces in the soil, though nothing clear and certain has ever been found. The lack of solid remains still leaves some questions open, but most experts agree that something from space burst in the air, and the energy from that burst caused the wide ring of fallen forest. It is strange to think about how quiet the world was back then. There were no satellites watching the sky, no early warning systems, no cameras that could point up at the right moment. If the event happened today, many people around the world would see it at once. There would be videos, measurements, and recorded data. But in 1908, only the people who lived in that quiet place saw the bright flash with their own eyes. Only they heard the deep sound roll across the trees. Sometimes I wonder what it must have felt like to stand there that morning. You look up expecting a normal sky, and instead you see something bright enough to make your heart jump. You feel the warm blast of air a moment later. You hear a sound that seems too big to belong to the world you know. Then, after it all ends, the forest around you is never the same. On June 30, 1908, the Tunguska region of Siberia experienced an event that changed the forest in a very short time. The area was wide and filled with trees. Most people there lived far apart and made their living by hunting, fishing, or herding animals. There were few roads, and travel could take many days on horseback or on foot. Life was slow and mostly quiet, with people following the rhythm of the seasons. That morning, a bright object moved across the sky. People who were awake noticed it. It was bright, and it moved quickly. Soon after, there was a flash and a loud sound. The sound spread across the forest. The ground shook. Trees fell for miles around, all in a radial pattern from a center point. Some trees were broken, others were stripped of branches, and some had burned bark. Animals ran away from the area. Birds left, and some paths became blocked by fallen trees. Local people described the event in different ways. Some said the air felt hot. Some said the sky turned red for a short time. Others said the light was so bright that it hurt their eyes. They were unsure what had caused it. Some thought it was lightning, though the flash was different. Some thought it was an earthquake, though the ground did not crack. Some wondered if it was a meteor or some other object from space. In the years after the event, outside reports slowly reached the area. Travelers and local officials wrote about flattened forest and burned trees. They noted that the area affected was very large. Reports estimated the damage to be over 2,000 square kilometers. Even though the trees were knocked down, there was no large crater in the ground. This suggested that the object had exploded in the air rather than hitting the ground directly. Leonid Kulik was a scientist interested in meteors. He organized expeditions to the Tunguska region in the 1920s and 1930s. The trips were long and difficult. Trains could take him part of the way, but then he had to travel by horse, river, and on foot. The terrain was challenging. There were swamps, rivers, uneven ground, and thick forests. Supplies were limited, and the weather could be cold or rainy. Mosquitoes and other insects made travel harder. Kulik and his team studied the area carefully. They observed the fallen trees and measured the pattern of the destruction. They looked for any remaining fragments of the object. They dug in soft soil and in swampy areas, hoping to find pieces. They did not find clear pieces of the object. They concluded that the object had probably exploded in the air. The force of the explosion pushed the trees outward, and caused fires in some areas. People who lived in the area had their own observations. They noticed changes in the forest and the land. Rivers sometimes had unusual foam or discoloration. Animals acted differently after the event. Hunters reported seeing fewer animals near the center of the destruction. The forest remained quiet for many years. Scientists later studied the possible causes. Most agreed it was likely a space object, either a small comet or an asteroid. As it fell into the atmosphere, air resistance would have caused it to heat and break apart. The explosion happened several kilometers above the ground. The energy from the explosion was very high. Estimates suggest it may have been equivalent to tens of megatons of TNT. This was enough to flatten trees for many kilometers. Maps of the area showed a clear radial pattern of destruction. Trees pointed away from the center of the blast. Some trees near the center were still standing, but stripped of branches. There was some evidence of fires caused by heat from the explosion. Soil and water samples taken later did not show large amounts of metal, which supported the idea that the object exploded in the air. The Tunguska event remained a point of study for decades. Scientists returned several times to gather new information. They used aerial photography, soil analysis, and tree ring studies. Some studies examined patterns in the growth rings of trees to determine the force and heat of the explosion. Other studies looked at the magnetic field to see if the explosion caused changes in the local environment. The event also attracted attention because of its size. There had been no human deaths recorded, largely because the area was sparsely populated. However, the energy released was far greater than most other known explosions in history at that time. Researchers compared it to volcanic eruptions and man-made explosions to understand the scale. Reports of the bright sky and unusual lights were recorded in other countries. Some people in Europe noted red skies at night around the time of the explosion. This suggested that dust, or particles from the explosion, may have reached the upper atmosphere. Scientists used these observations to help estimate the size of the object and the energy released. Kulik's expeditions provided the first systematic study of the Tunguska area. He took photographs, mapped the fallen trees, and collected soil and plant samples. He documented the area extensively. Later scientists used his work to guide new studies. Even today, his notes remain an important source of information. The lack of a crater led to different theories over the years. Some suggested a volcanic explosion underground. Others proposed a natural gas explosion. Later studies showed that the landscape and geological records did not support these ideas. The airburst theory, where a space object explodes in the atmosphere, became the most widely accepted explanation. Over the decades, research continued. Scientists studied how often similar events could happen. They looked at records of meteorites, comet fragments, and other objects. The Tunguska event provided a clear example of the power of airbursts. It helped scientists understand potential dangers from space objects and influenced studies of planetary defense. The Tunguska region remained remote. Access was difficult, and conditions were harsh. Travelers and scientists had to prepare carefully. Roads were few, and rivers could be used only in certain seasons. Winters were long and cold. Summer travel had to contend with insects, mud, and swampy areas. These challenges slowed research, but also preserved the site in a relatively natural state. Over time, satellite imagery allowed for new analysis. Scientists could see patterns of forest recovery in areas where trees had fallen. They could compare current forest cover with older photographs. This helped in understanding the long-term effects of the explosion. Some areas recovered faster than others. Soil composition, water availability, and plant growth affected the speed of regrowth. Studies also looked at the effects on wildlife. Birds and animals returned to the area over time. Some species were less common near the center of the blast. Others were able to move back quickly. Long-term studies provided information about how ecosystems recover after sudden events. Tree ring analysis gave more insight. By examining trees that survived, scientists could see evidence of the heat and force from the explosion. Scorched bark and unusual growth patterns indicated the timing and intensity of the blast. These studies confirmed observations made by Kulik nearly a century earlier. The Tunguska Event became a reference point in understanding airbursts. Scientists could estimate how large an object must be to create a similar effect. They could study energy release, shock waves, and patterns of forest destruction. These lessons helped improve understanding of potential risks to populated areas. In the 20th century, other scientists visited the site. They used new tools, including magnetic measurements, chemical analysis, and aerial surveys. They compared findings with similar events, such as smaller meteor explosions. Research confirmed that the Tunguska explosion had released more energy than all previous known events of its kind. Despite the large energy, human casualties were minimal. This was because the area was sparsely populated. People living in distant settlements reported hearing sounds or seeing lights, but no direct injuries were documented. The remoteness of the region limited the impact on humans. Later studies considered the possibility of finding fragments of the object. Researchers looked in soil, rivers, and lakes. Small traces of unusual metals were found, but nothing definitive. This supported the idea that the object mostly vaporized in the air before reaching the ground. By the late 20th century, the Tunguska event was widely accepted as a large airburst caused by a space object. Researchers continued to study the patterns of fallen trees, soil changes, and tree growth. The data helped improve models of airburst explosions and their effects on the environment. The event remains important in science. It shows that even a remote area can be affected by objects from space. It also shows how much energy is released when an object explodes in the atmosphere. The Tunguska explosion provides a real example of these forces in action. Today, the forest has grown back. Some areas have new trees, while others show patterns of older fallen trees beneath the current growth. The land looks normal to a casual observer. However, scientists can still find traces of the event through careful study. The Tunguska explosion is an example of how nature can change an area very quickly. Thousands of square kilometers of forest were affected in seconds. Trees that had grown for decades were knocked down. The soil and rivers were affected. Even though people lived far away, they noticed the effects in sound, light, and air. The event provides a lesson about remote events. Even in areas with few people, significant changes can occur. Careful observation and study allows scientists to understand what happened. In the case of Tunguska, years of study confirmed the event was a major airburst from a space object. Even now, the Tunguska event is referenced in studies of planetary defense. Scientists consider how often objects from space could hit the Earth and what damage they might cause. Models of airbursts, shock waves, and forest destruction all use Tunguska as a benchmark. The remoteness of the region limited the human impact. The forests absorbed much of the energy. Wildlife fled and later returned. Soil and water were disturbed but recovered over time. People living nearby noticed changes, but most did not understand the cause. The Tunguska event shows the power of nature from above. A single object, moving through the atmosphere, can change thousands of square kilometers of forest. It shows how events in remote areas can be studied and understood over time. Observations, expeditions, and careful research have allowed scientists to learn about the event nearly a century later. Kulik's work remains important. His notes, photographs, and maps provided the foundation for later studies. Even with modern tools, Scientists still refer to his records to compare data and confirm observations. The Tunguska explosion remains a significant event in the history of science. It was the largest known airburst in modern times. It has helped improve understanding of how objects from space interact with the atmosphere. It has also provided lessons for studying environmental effects of large explosions. The event occurred in a quiet, sparsely populated area. Its size and energy were extraordinary. The lack of human casualties was fortunate. The effects on trees, soil, and wildlife have been studied for over a century. The event remains one of the most well-documented and analyzed airbursts in history. Even though it happened long ago, the Tunguska event is still referenced today. Scientists continue to study the area. They use new tools and methods to analyze soil, trees, and the environment. These studies provide a better understanding of airbursts and their potential effects on populated areas. The Tunguska explosion is now accepted as a natural event caused by a space object. It is no longer seen as a mystery. The combination of local reports, scientific study, and modern analysis confirms that a large object entered the atmosphere, exploded in the air, and caused the observed damage. The forest has recovered over time. New trees have grown, and rivers flow as before. The area looks calm and quiet, but traces of the event remain. Fallen trees beneath the new growth still mark the area where the explosion occurred. Soil samples and tree ring studies continue to provide data about the energy released and its effects on the environment. The Tunguska event is important in the history of science. It provides an example of how a remote area can experience a large natural event. It also shows how careful observation and study over decades can reveal what happened even when few people witnessed it. The explosion was caused by a space object, probably a small asteroid or comet. It exploded in the atmosphere above the forest. The shock wave flattened trees, burned some areas, and caused changes in soil and water. People living far away saw lights, heard sounds, and felt the shake of the ground. Even with modern technology, the event is still studied. It provides a benchmark for understanding airbursts. Models of explosions, energy release, and forest destruction are based in part on Tunguska. Scientists continue to learn from it. The forest and land have returned to a state that looks normal. Wildlife has returned. Trees have grown. The rivers flow, yet beneath the surface, the marks of the explosion remain. Fallen trees, burned areas, and soil changes still show the effects of the event. The Tunguska explosion is a reminder of how a single object from space can impact the Earth. It shows that even in remote areas, natural events can have large effects. Careful observation, expeditions, and scientific study allow us to understand what happened. It remains one of the largest known airbursts in modern history. Its effects on the forest, soil, and wildlife have been studied for over a century. The event provides important lessons for understanding similar events in the future. Even decades after the event, the Tunguska region remained a place of interest for scientists, not only because of the explosion itself, but also because of how the environment responded afterward. The forest that had once been continuous had been broken apart, leaving clearings filled with fallen trees. Over time, new trees began to grow in the spaces left behind. The younger growth mixed with older, fallen trunks, creating layers that could be studied to understand how the explosion had affected the area. Researchers examined these layers carefully. Tree rings showed unusual patterns caused by sudden heat and shock. Soil composition revealed small traces of chemical changes, likely from the explosion's energy. By comparing these changes across different locations, scientists could estimate the direction and intensity of the shockwave. The rivers and wetlands in the region also showed signs of the event. In some places, small pools of water formed where fallen trees had blocked natural paths. Soil erosion increased in certain areas, carrying debris into streams. Plants near the center of the blast were affected more severely. Some species struggled to survive, while others slowly repopulated the cleared areas. Observations of this process help scientists understand how large-scale disturbances influence ecosystems over time. The human record of the Tunguska event was surprisingly limited. Most of the people living nearby were herders, hunters, or small-scale farmers. They did not keep written records. What we know about the initial explosion comes mostly from oral accounts collected years later. People remembered bright lights in the sky, a sudden flash, loud sounds, and the shaking of the ground. They also noticed unusual winds and the smell of burning vegetation. These first-hand observations were essential for scientists who could not reach the region immediately after the explosion. Kulik's expeditions in the 1920s and 1930s were groundbreaking because he systematically documented the region. He mapped the area of fallen trees, recorded measurements, and collected soil samples. He took photographs showing patterns that could still be seen decades after the explosion. Kulik's work was challenging. The terrain was difficult to navigate, and supplies were limited. Rivers had to be crossed carefully, swamps were dangerous, and forests were dense. Insects and weather added additional obstacles. Despite these challenges, he gathered detailed data that laid the foundation for decades of later research. Later scientists used more advanced methods to study the area. Aerial photography provided a view of the pattern of fallen trees that was impossible to see from the ground. Satellite images later gave even more precise information, showing areas where the forest had regrown and where remnants of the damage were still visible. Researchers could also use computer models to simulate the explosion and the resulting shockwave, testing hypotheses about the size and speed of the object that caused it. The explosion itself is thought to have been caused by a small comet or asteroid entering the atmosphere. Objects like this travel at extremely high speeds. As they move through the air, friction heats the surface to very high temperatures. Pressure builds until the object breaks apart in the atmosphere. This creates an explosion in the air rather than a direct impact on the ground. The Tunguska event fits this model. The energy released flattened trees over thousands of square kilometers, but left no crater, because most of the object's mass vaporized in the explosion. The patterns of fallen trees were consistent with a radial shockwave. Trees closest to the center were completely stripped and burned, while trees farther away were bent or broken. The forest provided a record of the force and direction of the explosion. By analyzing the tree patterns, scientists could estimate both the height and the energy of the blast. These studies helped refine models for airburst events and became important references for future research. Wildlife in the region responded to the explosion in predictable ways. Birds and animals fled the immediate area. Some species avoided the blast zone for years, while others returned gradually. Studies of this process helped scientists understand how ecosystems recover from sudden, large-scale disturbances. Plants also responded to changes in sunlight and soil conditions caused by fallen trees. Pioneer species, which are plants that quickly colonize open spaces, became more common in the cleared areas. Over decades, the forest began to return to its previous state, but traces of the explosion remained visible to careful observers. The Tunguska event also had effects beyond the immediate region. Observers in Europe reported unusual red skies for several nights following the explosion. Some scientists later suggested that particles from the explosion reached the upper atmosphere, scattering sunlight and creating these colors. While the effects were subtle, they were visible over great distances and provided additional clues about the scale and intensity of the blast. Even in modern times, Tunguska continues to be studied. Scientists consider it a benchmark for understanding airburst explosions. Data from the event is used to model potential impacts on populated areas. By studying Tunguska, researchers can predict the effects of future airbursts, including the distance shockwaves might travel, the potential for forest destruction, and the ecological consequences. In addition to scientific study, the event provides insight into the remoteness of Siberia. The affected area had very few residents. The sparsely populated forest limited human casualties. Even though the explosion was powerful enough to destroy structures or injure people, the location meant that almost no humans were directly affected. This contrasts with the potential consequences of a similar event occurring in a populated region. Tree ring studies have been particularly important for understanding the Tunguska explosion. Scientists examined surviving trees to identify changes caused by sudden heat or pressure. Trees showed abnormal growth in the years following the blast. Burn marks and stripped bark indicated the intensity of the shockwave. These studies confirmed the observations made by Kulik decades earlier and provided precise data about the timing and force of the explosion. Soil studies also provided valuable information. Researchers analyzed soil samples from the center and edges of the affected area. They looked for unusual metals or chemical changes caused by heat and pressure. While few fragments of the original object were found, these studies confirmed the airburst model. The soil retained evidence of sudden, intense energy passing through the area. As decades passed, the Tunguska event became a standard case for understanding similar phenomena. Scientists compared it to smaller airbursts, including those that occurred over populated regions with minor damage. By studying Tunguska, researchers learned how to scale observations to estimate the effects of explosions from objects of different sizes or compositions. This work became part of planetary defense studies, helping scientists predict potential impacts and plan strategies for mitigation. The forest, rivers, and wildlife eventually returned to a more stable state, but the event left a lasting mark on the region. Fallen trees remained visible beneath younger growth, providing a natural record of the explosion. Soil chemistry retained subtle signs of heat and energy release. Tree growth and regrowth patterns reflected the environmental stresses caused by the event. These traces allow scientists to study the effects of a massive airburst over long periods of time. The Tunguska event also illustrates the value of careful observation. Despite its remote location and the lack of immediate scientific attention, information from eyewitnesses, explorers, and researchers allowed the event to be studied in detail. The combination of oral accounts, photographs, maps, and modern measurements provided a comprehensive understanding of the airburst. Even today, the Tunguska explosion is a reference point for studies in astronomy, geology, ecology, and planetary defense. It shows how a small object from space can release tremendous energy in the atmosphere. The event demonstrates the potential for large-scale environmental effects without leaving a traditional impact crater. Researchers continue to study the site, compare new data with historical records, and refine models of airburst explosions. The explosion's effects on the environment were extensive. Forests were flattened, burned, and stripped. Wildlife fled and returned gradually. Rivers and wetlands were disrupted by debris. Plant growth was altered for decades. Despite this, the region slowly recovered. Observations of recovery patterns provide information about how ecosystems respond to sudden, large disturbances. The Tunguska event also serves as a reminder that the Earth is constantly affected by objects from space. Even small asteroids or comet fragments can cause significant damage. Studying events like Tunguska allows scientists to understand the risks and prepare for the possibility of similar events in the future. Even with modern tools, The explosion remains an important case study. Researchers use it to understand energy distribution, shockwave propagation, and ecological effects. Tree ring data, soil chemistry, and aerial photographs all contribute to a detailed understanding of the event. These studies allow scientists to predict the consequences of potential future airbursts with greater accuracy. The Tunguska explosion affected not only the forest and animals, but also the people who lived nearby. Even though few were directly injured, the event made life harder for those who depended on the land. Hunters found paths blocked by fallen trees. Herders noticed that some grazing areas were gone. Rivers and streams were disrupted, making fishing more difficult. The sudden destruction created challenges for daily life in a place that was already remote and difficult. In the months and years after the explosion, people worked to repair and adjust to these changes. They cleared paths, rebuilt small shelters, and adapted to new conditions in the forest. This work was slow and tiring. Every day involved walking long distances, cutting fallen trees, and carrying supplies. The job of restoring access and making the land usable again was difficult. People had to deal with insects, uneven ground, swampy areas, and the effects of weather. In some ways, this became one of the hardest everyday jobs anyone in the region could have had. Clearing the forest, rebuilding paths, and ensuring that animals could graze safely required constant effort and endurance. Leonid Kulik and other scientists who visited the area also faced similar difficulties. Traveling through the remote region was physically demanding. The forest was dense, rivers were wide, and sometimes fast, and the land could be swampy or uneven. Carrying food, water, tools, and research equipment required long days of walking and climbing. Even though this work was not done for survival, but for science, it was exhausting. In a sense, studying the aftermath of the Tunguska explosion was a kind of extreme everyday job. Scientists had to combine careful observation with long hours of physical labor just to record the patterns of destruction. Over time, the Tunguska region recovered slowly. New trees grew among the old fallen ones. Animals returned. Rivers and streams stabilized. Life in the area became calmer again, but the memory of the explosion persisted. People told stories to their children and grandchildren. Scientists continued to study the region. Each year, more data was collected, more maps were drawn, and models were improved. Despite the calm that returned, the explosion itself remained a vivid reminder of how quickly the world can change, answering the question about the worst everyday job. In this story is straightforward. For the people living nearby, the hardest daily work after the explosion was clearing the forest and maintaining paths, rivers, and grazing areas. They had to do this in a large, wild area with no help from modern tools. Every day involved walking long distances, cutting fallen trees, and moving debris. The work was constant, exhausting, and necessary for survival. The explosion turned ordinary tasks into enormous efforts, which made this one of the most difficult everyday jobs in history. Even scientists like Kulik experienced their own version of this hard work. They had to walk for hours or days to reach the affected areas, carry supplies, and carefully record what they saw. Their daily work was slow, tiring, and often frustrating, especially in the harsh conditions of Siberia. While their work was different from clearing paths or herding animals, it required constant effort and attention over long periods. In that sense, it also counted as one of the most challenging everyday jobs connected to the Tunguska event. The Tunguska explosion remains a subject of fascination because it combined natural forces, environmental effects, and human effort. The explosion itself, caused by a space object entering the atmosphere, was brief but incredibly powerful. It flattened forests, burned trees, and disrupted wildlife. The aftermath, however, required years of labor from both local people and scientists. People had to restore the land, adjust to new conditions, and live in a forest forever changed. Scientists had to document, measure, and understand the event, traveling long distances under difficult conditions. This combination of natural disaster and human effort explains why the work following the Tunguska event can be described as one of the hardest everyday jobs in history. Life became harder, not because people were in immediate danger, but because the land they relied on had changed dramatically. Every day they had to meet these new challenges. The explosion may have lasted only seconds, but the effects on the forest, the animals, and the people lasted for decades. The Tunguska event also shows how much careful observation and persistence matter. The people living there adapted, worked, and survived. Scientists documented, studied, and returned repeatedly to learn more. Both groups faced extreme challenges in their daily work. The forest eventually recovered, wildlife returned, and rivers stabilized, but the story of human effort in response to the explosion remains part of its history. The event continues to teach lessons today. Scientists use Tunguska to understand airbursts and the potential risks from space. It is also a reminder of how small populations and remote areas experience natural disasters differently. The hardest work may not involve direct danger, but it can still be exhausting and essential for survival. Clearing fallen forests, restoring paths, and understanding the land are all forms of work that test patience, strength, and persistence. Even now, over a century later, the Tunguska forest stands as a record of both natural force and human endurance. Fallen trees beneath new growth, soil patterns, and surviving vegetation provide evidence of what happened. The people who lived there, and the scientists who visited, turned difficult tasks into their everyday work. Their labor preserved knowledge and allowed future generations to understand one of the largest airbursts in modern history. So, the hardest everyday job connected to the Tunguska event was not just one thing. It was the combination of survival, restoration, and study. Local people cleared forests and maintained paths. Scientists explored, measured, and documented the effects. Both endured difficult conditions, long hours, and physical effort. In this quiet, remote part of Siberia, the work after the explosion became as significant as the event itself. The Tunguska story is calm now, but it was a reminder of the power of nature and the endurance required afterward. The forest, rivers, and wildlife recovered slowly. People adapted, scientists learned and recorded everything carefully, and all of this work, day after day, became the hardest kind of everyday job, long, tiring, and essential. If you enjoyed listening to this story and following the quiet journey through the Tunguska event, please subscribe for more peaceful history stories, and tell me in the comments which part of the explosion or its aftermath you found most interesting or surprising.